All right. Oh, thank you, Sharon. No, it's not. Okay. All right. All right. So here's the code to log into the Playground app. Robert said waiting for other people to join. And I know a couple of people who won't be able to join, but are just listening in, which is completely fine.
Hey, are we supposed to? I was having issues getting in. This is Janae.
Hey.
The this joinmyquiz.com.
Mm-hmm.
That's what we're supposed to go on.
Yeah, well, you should have the Wayground app already. If not, then
Oh,
you can just download it. It's the same thing. So you can
okay.
still go there on your device, if you don't have the app, but it might run better on the app.
Let's see.
I'll give it to like 6:08. Let's see. Music. All right. Okay, Janae, you figured it out. I see. I see.
Yes, ma'am. I just text Shamaya because she
Oh, you
reminded
did?
me about it. She
Oh,
hasn't
really?
responded yet, so
Okay. Okay. Because I know like people should be able to pop in without asking to be requested in. Because if we're starting, I'm not gonna be able to see the screen. So hopefully it'll pop back in. Mhm. All right, so we have 5 people so far. Like 2 minutes left. And then for those people who didn't come, they'll just they can look at the recording. I'll post that once it uploads from Zoom. All right. So anyone else should be able to join in throughout the time. So let's get started. All right, so we're gonna start at question 1. The most valuable type of research. All right, so let's take a look. So, A, always conducted using a factorial analysis. So be cautious of anything that says always, most of the time, something that's like definite, because research, the valuable type of research isn't a factorial analysis, right? It can be other things, right? But a factorial analysis is another word for an ANOVA, right? But there's also other ways that research can be effective, but the best answer here is when you do an experiment to test your hypotheses. So it will be a cause and effect relationship, right? So you have the IVDV, that's one group, and then you have the control group, which is the second group. All right, any questions about this one? All right. All right. So experiments emphasize parsimony, which means, right? So interpreting the results in the simplest way. So the idea is that why give the most complicated answer about your research findings? You can just give a simple one, right? Even though that's not the best, because I'm not thinking about or considering other things that influence my research outcome, right? Other variables, right? So instead of me just saying a flower grow because of um, water and soil and the sun and et cetera, I'm just saying, yeah, the flower grow because it's the water, right? It's the simplest answer, right? But it also takes away from other variables that impact the research outcome, right? All right, let's see. Okay. All right, so Occam's razor is the same as parsimonious. So parsimonious is like parsimony law, right, which says you can explain things in the simplest answer, and Occam Razor, right, is still underneath of that. It just means the fewest assumptions and the simplest answer. So it's two ways of saying the same thing. Occam's Razor was created by William Occam, right? And he was a philosopher, unnecessary information. Probably don't have to know that. But the idea is that you have parsimonious law, and then you have Occam's Razor used to say the simplest explanation is the best, right? When someone do their research, they say, oh yeah, I apply Occam's Razor, right? But parsimonious, they're both the same. Let's see. All right, got 5 seconds. All right. All right, good, right? So keyword is unbeknownst, right? We want to make sure that when we select participants and do screening that they fit the criteria for the research. All right, good. All right. So non-directive is to person-centered because with Carl Rogers, he once called his theory non-directive, then it went to client-centered, and now it's person-centered. So it's still related to each other, it's just a different name. The same thing with parsimony, right? So parsimony means simple, clear, sufficient explanation. And then the Occam's razor, you think about shaving off unnecessary assumptions, right? Appraisal is to research. So that would mean assessment is to research, not necessarily, right? In that sense, right? They don't always go together, like parsimonious and Occam's razor.
Say that one more time about appraisal to research.
Yeah, so appraisal is assessment, right? Is to research, right? So not every research has like an assessment, right? You could have interviews, right? And for qualitative, right? So every research that a person has done or the options for research doesn't require assessment. Just depends on what you're studying. Does that make sense?
Yes, it makes sense.
Okay, awesome. If anybody else have any questions, just let me know. Questions are completely fine. All right, so keyword here, and we can start doing the keywords as well, is confounded. We know last time confounded or flawed is when something is unknown to the researcher in the experiment, right? And so an experiment is said to be confounded, right, when undesired variables are not kept out of the experiment, right? So it's like knowing the are not versus are kept out, right? 'Cause if it's kept out, then it wouldn't be confounded or flawed in this case. Alright. C, basic research is used in place of applied research. No, not necessarily, that doesn't make it confound. It's just other ways of doing research. You can do research to do research to get some kind of understanding. Applied research is when you actually take what you've learned and apply it to real life situations. All right.
Okay, I got a question real quick.
Sure.
So confounded is flawed, correct?
Yep.
So, you said it should be in the experiment?
Should not be. So you don't want to have any experiment where it's confounded or flawed, right? So it should be kept out or not kept out. In this case, it's going to be confounded or flawed. But any experiment doesn't want to have confounded or flawed because that means that they probably have to do the whole research over. Right, but this example here or this question or statement is saying an experiment is said to be confounded. So what is considered confounded or flawed in an experiment? And that's just when undesirable variables are not kept out of the experiment. Did that answer your question?
Yeah, you know what got me? It was the wording.
Yeah, that's what I'm saying. Like one says are not kept, and then the other one says are kept. All right. Mm-hmm. All right. Anybody else have any questions? All right. All right, okay, everyone. I see you all. All right, so here's a quiz. Is the IV and DV, is it one group or two groups? And you could just answer. Is the IV and DV one group or two groups?
Two groups?
Okay, anyone else?
I'll say two.
Okay. All right, so we have the IV, right? So the IV and DV is actually one group, right? So I manipulate, right? So think about the IV, I manipulate. Right, and the DV is the results. You might see it as outcome of the manipulation. Right, and then the control group would be the second group. Right, because they don't receive any kind of manipulation. Right, the control group is where you just can compare the DV to the control group to see if there's a difference. All right, so this is what a basic experiment would consist of. In order to do an experiment, you would need to have two groups. So IV, DV, it's just the same group. Think of before and after. Right. Right. Any questions about that? All right. Let's see. And this, all the stuff that I'm writing down will be in the notes that everyone should have access to. At the end of the session, if you don't have access to it, let me know and I will send the link out to you. And I'll also put it in the Geneva app. All right, we're at about 5 seconds. All right. All right, let's take a look. Ooh, it's being weird. All right, so for some reason not letting me move up, but um, so biofeedback, right? So we're looking at a hypothesis, right? Hypotheses is also called an alternative hypothesis as well as a hunch, right? These both mean, all three mean the same thing. So hypotheses, alternative hypotheses, and hunch means that I'm guessing that there is a relationship, right? But in order for me to determine that, I need to do the actual experiment. Right. And so in this case, if I'm saying that biofeedback training can reduce anxiety, improve board exam scores, I'm more so implementing and I'm manipulating the group by bringing in biofeedback. Right. And then I look at the results and see if there was an improvement in their board exam scores by comparing it to the control group, right, that does not receive any kind of biofeedback. And let me know if I need to repeat that or write that down. Right. When we're looking at B, anxiety levels. So we're not giving people anxiety, right? Or we're not measuring anxiety, right? The main thing that we're looking at is the biofeedback training. The reduced anxiety is what's that word? Is a side thing that happens in the midst of this, that it could happen, right? As a biofeedback training can help, right? Reduce anxiety. Right. But that's not the main thing I'm focused on. I'm mainly focused on biofeedback training and board exam scores. Okay. Any questions about that one? Oh, here it is. All right. All right, about 5 seconds. All right. So experimenters should always abide by a code of ethics. The variable you manipulate and the one controlled in the experiment, right, is the IB or independent variable. I think some people see the control part and think about the control group, which I can see how that can be confusing. But it's more so saying I control the group by giving them the biofeedback or by manipulating them. It's probably not the best word to use. So if it was just manipulate in an experience, is the IB or experiment is the IB or DB. C says the variable you measure to determine the outcome. Measure. I mean, if you want to say it that way, but the wording or the professional term for this would be the IB or DV, so you can know who's being manipulated in the groups and not. Right. So the correct term would be IB in this case. Any questions about this one?
I don't have any questions, but I just wanted to tell you this was on my test.
Oh, this was?
Mm-hmm.
Ooh, okay. This exact question or similar?
It wasn't like worded the same in its form, but it was the exact question.
Okay. All right, good. Anybody else? Like, let me know if you've seen this. Oh, someone else said something?
Yeah, I have a question.
Yeah.
When you look at manipulate
Mm-hmm.
and you look at control, so you're looking at it's the same thing, right? Manipulation, you're
Mm-hmm.
controlling what's going on in this experiment, right?
Yeah, yeah, because I'm adding to that group. I'm controlling that group in that sense, right? It's probably not the best word to use because you have a control group that doesn't receive any manipulation, right? So we'll usually just say the group that you're experimenting with or you're manipulating. But in this context, yes, it's the same thing.
So you see something like this on an exam, and you see manipulation and control.
Mm-hmm.
Will we go with the first word, or we have to look at it as a whole?
I would say look at it as a whole, right? Because it'll give you an idea, right? So when we're thinking about the manipulate, it can't be the control group that's not receiving it. And also, too, when you're taking a test, it's not going to have both of them as an option to be confusing, right? So when you take the test, it should say just manipulate or you experiment, right? Is the what kind of group, right? So it's not going to have both of them to be confusing because
Yeah, that's how
that.
mine was worded. It said it's an experiment, and then it had like these answer choices.
Okay, yeah. But I would say if you know which one is being manipulated and you're looking at the keyword is manipulate, you could just take that out and just like say, okay, it's the IV or independent variable, right? So you can still look at it as a whole, but also look at the keyword. But when you take the exam, it's not going to have both options in the statement is what it's looking at. Does that make sense?
Yeah, that makes sense.
Okay, all right. I think Someone's on here twice. I'm trying to remove them. Oh, it's not working. All right, so I'm gonna end it. All right, let's see. All right, yes, everyone got that correct. All right, so yes, the control group and the experimenter group. Okay. All right, so in order for the professor of counseling education to conduct the experiment suggested in question 8, and that refers to the biofeedback rating board exam scores, the experimental group, right, would need to receive, right? They would need to have that biofeedback, right? And it also is that group that's manipulated, right? So it would be A and B. So for people who got A and B separately, you're not gonna have two answer options on the test, so technically still correct. Okay. All right. All right. So hypothesis testing is most closely related to the work of, so HAPHOC is careers. He looks at needs, a higher percentage of needs. So I think about that age for HAPHOC and careers. He said we choose a job to meet our higher or highest percentage of needs. Lord Morgan wouldn't be considered here, but R.A. Fisher. The way I remember R.A. Fisher is I think about fishing for significance, right? Because in the hypothesis testing, that's what I'm doing. I'm looking for a significance between two variables, right? So I think about R.A. Fisher as fishing for a hypothesis, right? Or a significance. Okay. Anybody have any questions? All right. All right. Mm. Oh, my apologies. Alicia, I thought everybody answered. All right, so the null hypotheses. Whenever I see null, I think of nothing. Right, so I imagine I'm having a conversation and I'm telling someone that, I hypothesize that biofeedback will raise board exam scores, right? I believe there will be some significance between that biofeedback and the board exam scores. And then the person I'm telling is like, I don't think it's gonna be anything there, right? It's gonna be a null, right? So think about null as nothing, right? So it's gonna be biofeedback will not improve the board exam scores, right? And when we're doing research, we're trying to prove the null wrong or right, right? So at the end of experiments, we can either accept or reject the null. All students receiving biofeedback training will score equally well on the board exam. So it doesn't connect with, I mean, you could say that in a sense, but that's just not the logical null hypotheses that you would have, right? So if they scored the same, are we saying it's because of that biofeedback they were scored the same? I mean, you could say it that way, but the technical way to say it is biofeedback will not improve board exam scores, right? Because you're looking for something that's negative, right? Equally doesn't mean like it won't happen or at all. Does that make sense? All right. All right, the hunch. Okay, I believe everyone answered. Okay, so the hunch, known as experimental or alternative hypotheses. The experimental hypotheses suggest a difference will be evident between the control group and the experimental group. Thus, if the experimental group, and it should say just question 8, were conducted, the experimental hypotheses would suggest, right, that the biofeedback would raise the scores, right? So anytime you see hunch or any of those other terms, I'm assuming that there's something there, right? And I have to do the research to prove it. When you think about B, the control group will score better on the board exam. That doesn't have biofeedback in it, right? So it doesn't look at how biofeedback plays a big part on the scoring better on the exam. There will be no difference between the experimental and the control group. That will be a null, right? Because nothing significant is there, right? So if the IB and the DV, you're looking at the results and they scored 108, and then you compare it to the control group with no biofeedback and they scored 108, there'll be no difference, right? Because they both still scored the same thing, right? So that will more so be like a null. The experiment has been confounded. No, it just means that if there's nothing there, it's nothing there, right? Confounded means that there's something within the research process that makes the results at the end wrong, right? And we don't say that here because we're not looking at if it's confounded or flawed in a sense of being messed up in the research to start with. All right. Anybody have questions about that?
Yeah, I got a question. Can you explain again, um, Why is not B again?
You said D?
Yeah.
Because there's nothing that's saying that it was something, well, it's nothing in this statement that is saying that there was something found within the experiment that made it flawed in the first place, right? We're just looking at what is the meaning of the hunch or experimental hypotheses, right? We're not saying it's flawed, right? It's not giving us information that a participant did not disclose that they were saying. I think one of the questions, a student did not disclose they were seeing a Gestalt therapist. Right now, my research is confounded or flawed, right? We're not looking at that as a lens, where we're more so looking at what does it look like if I have a hypothesis in an experiment based on question 8, right? How would it look? Right? Does
Okay.
that make sense?
Yes.
Okay. All right. Anybody else have any questions? All right. Okay. All right. So from a purely statistical standpoint, in order to compare a control group to the experimental group, the researcher will need to test for significance, right? So the definition of test for significance is a statistical process where the results of an experiment is to determine if the results of the experiment are due to the IV, which is the biofeedback here, right? Or if it happened by chance. And another way you can say it is there a difference or relationship we see in our data real or just random? Right? Did that biofeedback really improve board exam scores? Because in research, nothing's definite, right? It could have been something else. Maybe that class or the group already had the test before, right? So we want to make sure how much of significance is this. Did it happen by the IV with the board exam scores being raised, or did it happen by chance? Descriptive statistics is used when you're describing your data, right, at the end. And you're saying, okay, I'm using a bell curve, right? Or I'm using a bar or a histogram to explain my data, right? So that's what descriptive statistics is. Anytime you see correlation coefficient, it looks at the strength of the relationship between two variables, right? All right. Any questions about this? All right. And then let me know if I need to repeat anything or if I need to write it down.
Amanda, can I have the code? I just joined.
Oh, okay. The code's right here at the top is top left 218-990.
Got it. Thank you.
You're welcome. All right. Trying to see if I can move this one, but it won't let me move the person out. Okay, it did. Okay. All right. Okay, everyone got that correct, right? So probability, right? Think about how you roll a dice. What's the probability that you'll get a 7, right? Same thing in research, right? If I continue to do this research over and over again, what's the probability that I'm going to get the same outcome? Okay. Okay, good. And then keep in mind that social sciences is like the branch of science that study like human behavior, society, and social relationships. So if you want to do a short version, it's just social sciences study people and how they live together, how they interact with each other. Okay. All right, so R.A. Fisher, he's the guy who created this formula, I think in the 1800s or something like that. But the probability of 0.05 or less, right? Let me use this chart. Yeah. All right, so R.A. Fisher. Right, he created that term, right? Hypotheses. Right, and he also created the probability, which is also means like your p-value. Now bear with me. All right, so he said that the probability and p-value, right, has to be 0.05. All this means is that this looks at how much error, right? If I roll that dice, how many times would it be? Or if I give this test or pregnancy test, for example, what's the probability that it's going to give me an error, right? And he said you want to have at least equal to or 5%, or in this case, when you move the little decimal over, you can make it 5%. That's what I do, right? So you want to at least have at least 5% of acceptable error, right? This is the acceptable amount of error you can have in your research. Right, and that's based on that probability. All right. And if you have 4, 3, 2, 1, right, that means that you have less of an error, right? That probability of error is smaller. Right. So you might see it as p-value or just p, right? Just depends. They're both the same thing. Right. And you're gonna find this in type 1 errors that we'll talk about when we get to it. Okay. Does anybody have any questions about this?
I have a question.
Mhm.
So when you look at this question, could have been any science. We really don't care about that social science part. We only care about the probability level, correct? Okay.
Yeah, it's just saying all across all social sciences, this is the rule. All right, this is the acceptable amount of error. But for counseling, you're only gonna just focus on just psychology, right? Research, right? But yeah, but this is the standard through all disciplines in social sciences. Right. Anybody else have any other questions? Right, and then also too, I'll add that because I have this 5% error or 5% chance or probability of error, it's always gonna be out of 100. Right, you might see it as 1.00. All right, I just moved a decimal over to make it a percentage. So that means that out of 5% out of 100, right, that means that 95% of the research or 95% of the output pregnancy tests is accurate. All right, it's always going to be out of 100 when you think about probability. Right. So that means if that person takes that test multiple times, 100 times, right, in this situation, that at least 5 out of that time or 5% of that time is going to come up as an error. Right. All right. Okay, everybody got that one right. Right. Yeah. So when that's my over, make it a percentage, 5% chance of the difference between the control group and the experimental group is due to chance factors. Right, you might see chance factors or error. They both mean the same thing. All right. Okay. All right, so that 0.5, right? That 5%, I mean 5% is error. And 95% is accurate. So that's why C is incorrect, because it's saying 95% is error. When in fact, 95% is accurate and only 5% is error. So when you think of that p-value or probability, it's going to look at how much error is in the results, right? Yes, and so a difference truly exists. The experimental will obtain the same results 95 out of the 100 times, right? So that's that probability, like the roll of the dice. All right. Any questions about that one? All right. Okay. All right, so we're looking at the one that rules out the best chance factor, right? So A is the acceptable level, right? But the one that we want to rule out is the smallest number. So anytime, rule of thumb, anytime you see more than 1 0 in front of the number, like in C, then it's smaller. All right, think about how a calculator looks when you have all those zeros and it goes on like forever and it has numbers in the back, right? So this number is smaller, right? So that's why it's not B here. Anyone have questions about this one? So A is the acceptable level, but I'd rather have the smallest number here when it comes to chance factors of the results being error or the outcome being error. I would choose C. All right. Okay. All right. So type 1, type 2 errors. The way I remember if it's alpha or beta is I think about 1 as the first letter of the alphabet, A. So type 1, alpha. And then same thing for type 2, second letter of the alphabet is B, beta. All right. Okay. All right. So type 1 error, right, is when you reject a null when it's true. So for short, a type 1 error is when you have a false positive. Right. So remember that we talked about earlier, the goal of research is either to reject or accept the null. Right. But if I make up something and say, yeah, there's a significance here, right? And then all of a sudden someone goes behind me and checks my research and says, there's actually nothing there, right? Instead of me initially rejecting the null, I should have accept the null. Right. And then B is you accept the null when it is false. That's a type 2 error, right? That's me assuming that there's nothing there. And then someone again comes behind me like, you know what, you missed a step, right? So you should have actually rejected. And I know it's weird, right? Because it's opposite of each other, but I can also write that down as well so you can know the difference. So let me just see.
Can I give them my memory device?
Sure, go ahead. I'm all for it.
So how I remember like which one is which, if you
Mhm.
reject first, it's the type 1. If you accept, I don't know. It sounded right in my head.
Hey, it's okay. It's okay.
Accepting when false, you reject when true. I don't know. It sounded right in my head. I'm
Hey,
sorry, guys.
look, the intention is there. It's okay. You are not alone in yourself and how you feel, especially trying to make sense of it. All right, so type 1, we know it's, oops, not beta. We know it's alpha. And we know this is beta. Right? So type 1 is pretty much a false positive, right? That's like me presenting something and lying about the research and saying that there's something there and it's not. All right, and because I'm lying, in order for me to maintain my lie, I'm going to have to reject the null, right? I'll tell that person who says nothing will be there that I reject you because there is something here. There is a significance, right? So a false positive is when I at first reject the null. Right, so at first I reject the null, right? Because I said there is a significance here. All right, so because there is significance. All right, and then someone comes behind me and says, hey, you know what? You know, in research, people have to go behind you and redo your research just to make sure it's accurate. So if someone comes back and replicates my research and they find that, oh, there's nothing there, they would tell me on second thought, you should have just accepted the null. Right, so you should have accept the null. Right. So first they rejected the null, right, when they should have actually accept the null. Right. Any questions about this type 1 so far? Okay. So in order for me to figure out, right, how would I know this person, if I went behind them, how would I know to say, hey, this is a fake significance. This research is incorrect, right? So how do I determine that? So how do I determine if the research results are, I don't want to make it lengthy, but how do I determine if the research results reject or accept the null? There's different parts of research where you would go in and check everything. So that's why you have to have someone come behind them and check everything as far as their steps, what they've done, right? So I'm gonna make this line a little longer. So in order for me to do that, I will have to do a formula. Right? So it's gonna look like the p-value. That's why the p-value is here, right? So p is that probability, right? Probability of error. So at the end of the research, you know, I put this into SPSS, right? SPSS or some kind of tool that takes all my data and pulls up a number, right? It's going to give me my p-value, right? And we talked about that before, about the p-value, right? So if my p-value is 0.5, well, let me make this more spaced out. So if it is 0.05 or less, right, that means I'm going to reject the null. All right. But if it's something that's higher then 5% in this case, or 0.05, right? Maybe if it's 0.06, then I'm going to accept the null. It's too much error there. All right. So you might see the formula look like this. Or you might even just see it with a 5 because it's higher than a 5. All right, so if we see, oh, P is greater than 0.05, right? Then I'm going to accept it all. Too much error there. Right, because in social science, the acceptable, according to R.A. Fisher, is 0.05. So anybody have any questions about this one? I know it was a lot to take in, so feel free to ask me questions. But just, I would say the key things to look into this will be type 1 is reject the null when you should have accepted null. Right? So here and here, and then that p-value, right, is here. Knowing that p-value stands for probability. Right? And if anything is equal to 5 or less, right, then I'm going to reject the null because there's some significance there. Okay. So now we're going to talk about the type 2, which is beta. Right, so this is a false negative. Right. So at first, I say, you know what? I accept the null. It's nothing here. I wasted my time doing research. Right. So I'm just going to accept the null. Right. Because there is no significance. Right. Right. And then someone goes behind me, right, replicates my research and says, you know what? It's on second thought. Right, you should have rejected the null. Right, maybe you did a miscalculation or something like that. Right, and now there is a significance here. Right. So keywords here, just going through it, is accept the null when you should have rejected the null. Right, and then once again, how do we determine this? So you might see something, it's not a formula like it is here with the p-value. But for this one, we're looking at what's called statistical power. All right, so in the beginning of the research, I have my hypotheses, right? I'm assuming that there's some kind of significance there, right? Statistical power is me guessing. Let me make this on the other line. It's me guessing how much my research is accurate. I'm guessing how much the significance is, I would say, or I would say how much of my research is accurate. So how much my research will be accurate. All right. So if I tell my friend, hey, I'm doing this biofeedback research, I feel like it'll improve board exam scores. And I'm thinking that my statistical power would be maybe 0.20. Right, that means that I'm assuming that 20% is error, while the 80% is accurate. That's me making an assumption. Oops. And then at the end of the research, I can see if my assumption was right or wrong. Right. So, any questions so far with the statistical power? Did I lose anybody in the mist?
No, that was good.
Okay, okay.
No.
Right. Okay, yay! All right, so yeah, so statistical, so just keep in mind, you see type 2 error, statistical power is a key term. I'm just making a guess about how much of my research is accurate or not. There's no formula, it's just me comparing what I assume to what's actually the results there. Okay, all right. And then also I wanted to bring up with the that question of the what's that, the 0.5, hold on, 0.5, right? We said that's just 5%, right? And that just means that it's a 5 in 100 chance, right? That the results happen by chance. So 5 in 100, the results happen by chance. Right, so I'm gonna make this orange. So I don't know if you're gonna see it on the test, but it just looks at the roll of the dice, right? So 5 in 100. Right, and then when we look at the 0.01, right, that's at 1% chance, and that's 1 in 100. And it doesn't change no matter what, so it's always consistent, right? And then that 0.001 we saw, that's smaller because that's a 0.1, right? So that is a 1 in 1,000 chance. Oops. Just so you can have that context. Right. So the best one that we would want to have is the 0.001. So I just wanted to go over that. All right. Oh, did it kick me out? Oh, did it kick everybody else out? I'm not sure. Oh. All right, so let me try to figure this out. Should have still been there. I'm sorry. Hmm. All right, so you might have to log back in, unfortunately. I'm not sure what happened. So weird. Okay. Let me just end this. I think I can end it. End presentation. And okay, let me get up. Sorry. To go backwards. Okay, y'all bear with me. I don't know what's going on now. All right, let's see. All right, so unfortunately, everyone have to log back in. Maybe it was like I was too idle for too long, I guess. I think we had like eight people, I think.
It's not allowing me to log in.
Really? Try to log out of your are you on the app or the computer?
The app.
I would try to say like close it and try it again. Like close completely out of it and try to log back in and try it again. Okay. All right. So I think it was another person, but I can't remember who it was. Anybody else still waiting to log in? Or still logging in? All right. If not, then we can continue. All right, so I'm gonna skip some questions. And the timer's on here now. All right, so let's go. So we're looking at type 1, type 2 errors. All right, so I believe we stopped here, but type 1 error occurs when you, right? You can start here just to review that one. I'm gonna take the timer off here. Hold on now. I think it did something by itself. Okay, way ground, way to go. Okay, so even if you didn't answer right, you reject or null when it's true, right? So let's see if it happens on the next one. Okay. All right. So shorter answer here. So even if you just got A or C right, it's still correct. Right. On an exam, you're not gonna have both A and C anyway. As a two answers that are correct, you're just gonna have one answer that's correct. So either way, it's still correct. All right. And it should be question 8, not 708. Hold on. Oh, that stupid timer. My apologies. Let me try to go back. Let's see if I can. Can I restart it? No. I don't know why it's a timer on here. All right, so just going over it anyway. Assume the experiment in question 8 is conducted. The results indicate that the biofeedback helped raise written board exam scores, but in reality, that's not the case, right? So this would be it would be a type 1 error, right? Because it's a false positive, right? So that key part right here at the end says, but in reality, it's not the case, right? So this will be a false positive. Right. Anyone have any questions about this one? I know everyone did get to answer. I think the timer went off. Okay. I'm gonna take this timer off. Okay. All right. So, um, a counseling or counselor educator decides to increase the sample size of the experiment, right? So it was going to reduce type 1 and type 2 errors in general because the bigger the population that I get, right, I would get more of the average, right? So imagine if I had 3 people in my experiment. So N, you might see N equals number of people in your experiment. So my N is like 3, right? Versus my N being 3,000, right? The bigger the population that I get, the more of the people that I can get in the experiment that I want, right? So the errors will have a decrease. All right, any questions about that one? Okay. All right, so for research change to significant level from 0.05 to 0.001, we know that means 0.1, right, is smallest number, right? Alpha errors will decrease, so that means that there won't be a large amount of false positive, right? But it could mean, right, that there could be a false negative, right? I'd rather have a false negative than a false positive in research, right? And so that's just the difference between the two, right? It's pretty much perfect, right? It's like 1%, 1 out of 1,000, I believe, right? Anyone have any questions about that one? Okay. Okay. All right, so the council believes that clients will receive assertive trainings will ask more questions in counseling classes. An experimental group receives assertive training, while the control group does not, right? So we have one group is receiving the assertiveness training, right? And then the other group does not, which is a control group, right? The key thing that helps me remember that it's a T-test or student's T-test is that T stands for two groups, right? So I know that I will be using, or they will be using a student's T-test, right? So a T-test just helps me break down my data into a chart, right? It's a complex chart. You can do it by hand. I'd rather not, right? So for a T-test, think about two groups, right? You will use a T-test in the system when you put in all your data. Okay. Correlation coefficient is it's going to be the strength of the relationship. So you'll see something in a question that says, what's the strength of the relationship or significance in the relationship between two variables, right? So you'll see some of those like keywords there. Okay. Okay. All right, let's just take a look. So I know I'm gonna break this down. Let me go back to the question. So one group receives no assertiveness training. We know that's the control group. A second group receives 4 assertiveness training. And then the third one, right, receives 6. Right. So the category is still the same. It's still assertiveness training, but there's 2 different groups that's receiving certain amounts, right? It's not the same, right? So let's break this down. All right, so you already know a T-test is when you have in a control group. Right, control and experimental group. All right, so now we're looking at an ANOVA. Right, so I'm gonna put it here. ANOVA just stands for analysis of variance. All right, so ANOVA is used when you have 3 or more groups, right? So I would say 3 or more groups when comparing means, right? You're comparing the means of every group that's there. Right, also means average, right? So that's like a general definition of ANOVA, right? When you have 3 or more groups when comparing means, right? You're comparing means to see, to identify significance between those 3 or more. All right, so that's like the general definition of ANOVA. Now you see ANOVA, you know you're gonna have 3 or more groups, but there's different kinds of ANOVAs, right? The example you just saw, it's an ANOVA, but it's also I would say a two-way ANOVA, but let's talk about a one-way ANOVA first. Well, it'll be a one-way ANOVA, but let's just talk about it first. So one-way ANOVA, right, is when you have one IV. That's how I know the difference between a one-way ANOVA and two-way ANOVA. One-way ANOVA has one IV, and a two-way ANOVA has 2 IVs, right? So when you have one IV with different levels, and I'll give you some example. All right, so maybe I'm looking at shoe brands, right? Oops. Right, and this will be like my IV here, right? Like I'm looking at the category of shoe brand. So this would be considered a category, only because I'm labeling, right? Category is more like when I'm labeling something I can name, right? Anything I can name, it's a category. So this name here is I'm naming like shoe brands. So maybe I want to figure out which shoe gives the best jump shot. All right, even though this is not a full hypothesis, but I'm just giving you an idea. So so now I have maybe Jordans within this one IV, right? Maybe I have New Balances. Right, so I have subcategories within this IV, right? So maybe I can add Nike and so forth, right? These would be considered more than one group because these are subgroups within this IV, right? And that's where the levels come in. All right, so one way ANOVA will look like this, like an IV with multiple things happening within that one IV, one category. Any questions about the one way ANOVA? Okay.
Nope.
All right. All right, so now we're gonna talk about two-way ANOVA. We already mentioned that a two-way ANOVA is when you have 2 IVs. So two-way ANOVA, right? So when you have 2 IVs, right, and you still have with different levels. All right, so maybe I have just like one IV here, one IV here. I'm looking at like males, females, right? Now I'm looking at teaching styles, right? One IV teaching style. Same thing here, teaching, right? I can also look at grades, I can come up with a number of things that I'm looking at. Right, grades within this class. All right. So I have two IVs, right? That has different categories, right? Of what it's measuring, but I can also have different levels of it. Right. And then that DV, in this case, would just be, okay, what was the outcome? I'm gonna probably most likely have a comparison chart of what this means, right? Well, I'm just looking at teaching or grades, right? So that's what that means here. And then this one just has the DV. Right, what's the outcome? All right. Two ANOVA, two IVs, one ANOVA, one IV. Right. And then we go back to this question here. Right, we're looking at the same thing, right? Assertiveness, assertiveness, assertiveness. So this will be a one-way ANOVA, right? Because I'm looking at one thing. Right, I'm looking at assertiveness. Now, if it was assertiveness and aggression, right, that would be two-way ANOVA. Right. All right. Any questions about that one? Okay. And also, so why it's not a two-way ANOVA? Because it's a one-way. All right. Okay. All right. So the median is underneath the central tendency, right? It has mean, mode, median, range, right? So if we're looking at the two-way ANOVA, right? We have two different IVs. Right. So what would be which is the mean? Okay. Anybody have questions about this one? All right. Moving along. All right. Okay. All right. So, a t-test, you will use a table value of t. Table value of t is a whole like chart that we have to like add and divide and multiply. So it's kind of complicated, but we can put it in a computer and they can do it for us. So we want to reduce human error, right? So when I put all my data in there and I say I select a t-test, it's automatically going to do a table of t. And for ANOVA, it's automatically going to be do a table for F values. Right. It wouldn't be B because that would be for a t-test there. Anybody have any questions? All right. Okay. So which level of significance will best rule out, right? We're looking for the best rule out, right? Not the acceptable level here. Right. So the best one will be D, because we talked about how that is 0.1, which is 1 out of 1,000. Right. Anybody have any questions about that one? All right. Okay. All right. All right. So I don't know what happened. The timer was off, I believe. All right. Right. So and the relationship between the IQ and panic disorder, right? Anytime you see correlation coefficient, right, we're looking at the strength between two variables. So when a researcher uses correlation, there is no manipulation. So correlation coefficient is not an experiment, right? It's like me going to look at other people who did this experiment, and I'm just looking at the data and looking at the strength of the relationship, right? So it's a non-experiment, right? And then the experiment would actually be like the experiment literally where I manipulate, right? But for correlation coefficient or correlation, I do not do any manipulation. No. All right. Let me make sure that this time is not running. All right. Okay. Right. So that correlation, right, is positive, right? Because it's been proven to improve board exam scores in this case, or the other question. But this one looks at more so, right, correlation between study time and LPC exam scores, right? So that means that there is a relationship between them. All right, good. Okay. All right, so I'm not sure. I took a time off. All right, so which of the following would most likely yield a perfect correlation, right? Inches and length in centimeters. Now let's look at the correlation, the actual scale that's used. All right, make a new sheet. So we're looking at correlation coefficient. All right, so it looks at the strength of the relationship. Right, between two variables. right? So the scale is gonna go from +1.00. Imagine just moving that decimal over, make it 100%, right? Correlation all the way to 0 down to negative. Right? Negative doesn't mean there isn't a correlation. And we'll look at that in a second. So as any of these correlations get closer to 0 going this way, right? The strength is really weak. It gets weaker and weaker. It goes from strong all the way to weak. And then 0 would look like 0.0. It'll be no correlation. All right. So when we look at like something that has a perfect correlation, right? That means that when one goes up, the other one goes up, right? So in centimeters and inches, they both go up, right? No matter which way they go, right? It'll be down here too. Well, not in the negative, but it'll be more so positive because one goes up, the other one goes up. Then you think about negative correlation, that's like one goes up and then one goes down, right? So we could think about this with weight loss, right? Maybe I work out more, right? And then I lose weight, right? And that relationship can be strong, moderate, or weak, right? And it goes both ways, right? So you will have strong, and this is perfect. And it's different numbers, it's the same, but you don't have to remember the numbers, just know that it gets closer to 0, right? The weaker the relationship. So strong, moderate, and then weak. And it goes the same way this way. So strong, moderate. Oh, kind of made that real close, didn't I? All right, let me fix that. All right, so strong, moderate, and then weak. Right. And of course, like I said, no correlation. All right, so on this one is inches and centimeters. All right. So that's correlation coefficient in the scale. There it looks at it goes from negative 1.00 all the way to plus 1.00. All right, so you might even see it look like that. All right, so that's what the correlation coefficient does. And keep in mind that this is a non-experiment, right? Because I'm not manipulating anything. All right, I'm also looking at data that's already out there. Okay. Oh no, did it kick me out? Okay. All right, about to say. All right, let's see. Let's go to the next one. Oh, not the timer. Okay. All right, so if I had to guess, right, a correlation, right, doing a statistical power, right, guess, or just a correlation guess, I would say 0, close to 0, like it's a weak correlation. Or you might have some people with the big baby toes or baby toes and they graduated with the NCE, but that's like a really small number, right? If I had to guess, right? Perfect would be that that actually happens, right? There's this perfect correlation between baby toes and people who pass their NCE. So that means that I can look at someone and say, hey, let me see your toes, right? And then I see your toes and I'm like, oh yeah, you can pass the NCE, right? That's like a perfect correlation, right? And the same thing for C as well. All right. Oh no, timer. Oh, okay. So this here is an example of a, I wouldn't say a false, it wouldn't be a false positive, right? Because he's presenting this research as if it means something else, right? Because he has this high correlation, right? It's almost perfect. It's 0.90, which is 90%. Right. I'm assuming it's positive because there's no negative symbol in front of it. Right. So he's taking someone else's research and looking at the results and using it to say something else or to state something else. Right. And so this is why correlation does not equal causation. Right. Someone can say there's this strong relationship between two variables, right, and say that, oh yeah, this causes that. But keep in mind, cause and effect is an experiment. And correlation is not an experiment, it's a non-experiment, right? So correlation does not equal causation. Those are two separate things. So maybe if I found a significance in my research using correlation coefficient, and then I say, you know what, there's something here, right? Maybe it's like 0.90, and I go and do the actual research and experiment to see if they actually cause each other, right? Does A cause B to happen in this case, right? And then when we look at suffers from longitudinal and maturational. So longitudinal means that I'm doing a research that occurs over a span of time, right? If I want to look at a child growing up and I do the study all the way until they're like 12, right? Maturational effects is that same child is going to mature. So the research question might change, right? Because that child is growing and thinking and doing things differently. It could impact my research in a good way or a negative way, right? So we got to keep in mind about that process. All right. Any questions about this one? All right.
What was the answer again? I missed it.
Oh no, that's fine. Correlation does not imply causal or causation, right? Because he's saying that that research that he pulled, a correlation research, right? He said the keyword causes therapists to become behaviorally oriented. Right, so he's pretty much lying at this point, right? So correlation is not equal causation. Those are two separate things. Correlation, non-experiment, cause and effect, experiment. All right.
Thank you.
You're welcome. Take this time off. Now keep in mind, N means number of participants in the study, right? So this person has one person in their study. Okay. So, behaviors, right? Behaviors, they modify behavior like B for B.F. Skinner or B for John B. Watson, right? They were all behaviors, right? They had one person, right? That they are one animal, right? That they used in their experiments, right? And so it would be anytime you see intensive experimental design, it's more so going to be around behavioral modification. Right. So if I'm trying to modify a person's behavior, I need to understand what their behavior is. What's the baseline? How often do they do whatever that they're doing that needs to be changed, right? How is it triggered, right? So that way I'll know if my intervention is working or not to reduce those behaviors. All right. And then compute the range, that's more so the central tendency. And that's done in another part of research. Let me take this timer off. And then this will be the last question, and then you all can ask me questions at the end. Okay. So single blind study is when only one part of I would say one part of the experiments where either the participant doesn't know what's going on or the researcher. It can be either or, but one of those people that does not know what's going on, right? One person, the experimenter knows who gets a placebo, but the participants do not know anything, right? So that's a single blind study. A double blind study is when both the researcher or researchers, as well as the participants, do not know who's getting the placebo, right? The goal of doing that is to make sure that there's nothing, no biases in research, right? And that's why that's done there. All right, it's 8:01. Um, I'm going to go to the board and I want to write down some terms. And you can all ask questions while I'm writing this down, but I'm writing down terms for words that are often used in quantitative. So you'll know the difference between quantitative and qualitative. Right. So these are quantitative keywords. And on the other end, it will be the qualitative. And while I'm doing this, anyone can hop off and ask any questions or just tell me how they felt the group went, anything I can improve on. Just overall, how did they feel about doing this when it comes to research now?
I feel like I understand research a little more. I mean,
Mm-hmm.
it's the subject that I dislike. So I understand it a little better now. So I think it went.
Mm-hmm. Okay, good. Yeah, that's the goal. So in research, it's not so that you can do it, it's so that you can understand, right? When someone else comes out for something for therapy, and you're like, well, what's your p-value? Right? Was your statistical power correct? They were like, hold on, wait, how do you know that? Right? Um, so anyone else have anything?
Are there a lot of research questions on the exam? Do you know?
For CPCE, it's the equal amount, so it's like 20 questions, but only 17 are counted. And then when it comes to the NCE, I've seen as small as 2 questions versus 12.
Okay.
Right, so the research is the smallest part
Yeah,
Okay.
on the exam.
it's not
Okay.
that many. The first time I took it last year, it was out of 3.
Mm-hmm.
When I just took it, it was out of 5.
Mm-hmm.
What was where did you see the most? Like
The
counseling
most
skills or whatever?
It was t-test on there. It was independent variable on there, and it was t-test on there. And I can't remember the other questions, but I know they had the answer choices like ANOVA, and that was ANOVA, and that's all I remember. But t-test was on there, and independent variable was on there.
okay.
All right.
And
Thank you.
then when it comes to the bigger parts of the test, it will be counseling skills, intervention, areas of clinical focus, intake assessment, and diagnostics, counseling, help in relationships, and sometimes professional orientation and practice, right? And
Okay.
then assessment.
Okay. Thank you.
You're welcome.
Oh, you know, you're right. I think it says that I'm in the Hellwood book. It says that counseling skills and interventions 48 questions,
Mm-hmm.
allegedly.
Mm-hmm. Yeah.
Yes.
Professional. Yeah. Okay.
Mm-hmm.
And
Yep.
then areas of clinical focus is 47 and the rest are just 19, 14, 13. So
Yeah,
Mm-hmm.
okay.
that's right. That's correct.
Okay.
Yeah.
Thank you.
You're welcome.
But I
Anybody
think this
else?
was really good. And you know what I'm getting ready to say? I'm so mad that we didn't have this before I took it, because if I would have got those 2 questions right, I would have passed.
Oh yeah, yeah. But hey, you here now. That's all that matters, right? And you're learning so that you can pass it next time and never have to see this stuff again. Anybody in this class have to see this again. Burn your books. Like, don't explain, don't do that.
Wait, was
But
it hard? Was it hard when you took like, or is it like easier than you thought?
Mm,
oh,
I wouldn't really say it's hard. I would, if you study good,
Mm-hmm.
no, I wouldn't really say that it was hard. It tests your
Okay.
knowledge though, but it's not really hard. If you know the material, it's not really hard. Like if you see
Okay.
all the sections out of that purple book,
Mm-hmm.
it's not really hard.
Okay.
But you do need to read the questions a few times.
Mm-hmm.
cricket.
That's what gets me is like I'll read the question and I think I know the answer. I hit it and I'm like, oh, like no, I like read the question completely wrong.
Mm-hmm.
Like I think I need to just like slow down and maybe really process what it's saying.
Yeah.
Yeah. So I always tell people to, and that's, I think some people might know this, but it's RIP. So I always tell people to read everything twice. Like sometimes we add stuff there, we take things away that's not there, right? And then identify the keywords, right? And then use the process of elimination. And when you use the process of elimination, are you going to focus more on who do you know, right? Versus who you don't know. Because who you do know, you can say, oh, I know this person, right? So they probably wouldn't have this keyword in their theory, right? Sometimes when people see somebody like, oh, I've never seen that name before. Who's that, right?
Right.
Mm-hmm. And so that'll help you be able to take the time and go through the questions and identify the keywords, right? And tie it. I always think about a little line going from that keyword to each of the answer options and seeing if it fits, right? But if it does not fit into a theory and you have not heard it before, don't try to make it fit. Right. Alright. Anybody else have any questions? So these are the words up here, quantitative keywords and qualitative keywords that you might see. Okay. Otherwise, I'm gonna put out a vote in the Geneva app of the next subject that we want to go over. But anyone have any consensus right now about the next subject they would like to go over out of the 14?
A large section
All
that's
right.
gonna be on the exam.
Okay. All right, so I called it my big six question, big six areas, or my fave six back in the day. All right, don't, I'm older. All right, I will make that announcement in a couple of weeks. So we'll have a next one soon. And then thank everybody for being here. And I hope everyone enjoyed
Thank
it.
you.
You're all welcome. And then I'm gonna put the recording in the classroom sometime tonight. And then I'll talk to you all some other time. And feel free to reach out to me, text me, or send me an email if you have questions. But thank y'all for
See
being
ya.
here. Good job tonight.
Thank you.
All right then.
Yeah.
Thank you.
Bye.
Enjoy
No
the rest of my
problem.
night.
Are you
You
too?
too, Lynn. Thank you.
All right, no problem. Bye.